Today, we are solving problems that involve direct variation. That means that we are looking at proportional linear relationships. We can say that y varies directly with x whenever these two variables are proportional. Let's look at some examples of this. First, we're going to write down a formula that should be familiar to you. It's k equals y over x. And in 7th grade, this is on the formula chart. We call k our constant of proportionality. This is also going to be the same as the slope of your line when you have a proportional relationship. So let's create an example here together. I want you to plot these points with me. 0, 0, 1, 3, and 2, 6. Take a moment to plot those points. And then let's label them. And let's draw a line through them also. This is a proportional linear relationship. You can always recognize a proportional linear relationship on a graph because it will go through the origin, or point 0, 0. So always pay attention when you graph a line to see, does it go through the origin or not? If it does go through the origin, that's a proportional linear relationship, and we can say that y and x vary directly. A proportional line goes through the origin. All right, so now let's take a look at our formula and see if we can use our formula to find the constant of proportionality, which will be the slope of this line, since this line represents a linear relationship that is proportional. All right, k equals y over x. I'm going to try it with all three of my points. Let me get some more space here. So first of all, k equals 6 over 2, because the point 2, 6 is on the line. So 6 over 2 just means 6 divided by 2. That's 3. So I could say the constant of proportionality, which is the slope, is 3. Let's try it for another point. I have the point 1, 3. So my y goes in my numerator and my x goes in my denominator. 3 divided by 1 is 3. In fact, almost any point that I pick would work. There's one point that you cannot pick to find the constant of proportionality, and that is the origin. So don't use 0 over 0. That will not tell you the constant of proportionality for the line, because 0 divided by 0 is 0. It doesn't tell me anything about how steep my slope is or how y is related to x, except for at that one point, 0. So use the other points when you are trying to find your slope. All right, now let's look at what this would look like in a slope-intercept form. With slope-intercept form, your m represents your slope, and your b represents your y-intercept. I like to say that we multiply by m and then we begin at b. That's a helpful way for me to remember which is which. All right, so let's write y equals 3x because the slope of our line is 3. Every time it goes over 1, it goes up 3. And then our y-intercept describes where it crosses the y-axis. Remember, we drew a big red box around that. I'll highlight it now. This is where it crosses the y-axis. At that point right there, that's the origin. So when I add b, I'm just going to be adding 0. So y equals 3x plus 0. Of course, we don't normally write plus 0. We normally would just write y equals 3x. That's all that we need to write here to write the equation of this line, and it'll be true for any point. Let's substitute a couple of points in so that we can see that. So I'm going to write x over here and y over there. Let's start with the points that we actually have in our graph. So we have 0. And then to get to y, I'm going to need to multiply 3 times 0. That's 0. All right, and that's one of my points, right? The point 0, 0 was on my graph. Okay, what about when x is 1? So then I would have 3 times 1, and that would be 3. That's the point 1, 3. What about when x is 2? Then I would have 3 times 2, and that would be 6. 2, 6. Let's try some other points that we haven't put on our graph yet. Maybe we want to try some negative values. What if I had negative 1? Then I would have 3 times negative 1, and y would be equal to negative 3. What if I had negative 2? Then I would have 3 times negative 2, and y would be equal to negative 6. So we're substituting points into the formula for our line. I want to go ahead and graph these last 2 points here on our graph. So I want to graph these ones right here. Let's see, our first one would be -1, -3. I'm going to zoom in. Here's -1, -3, and look, that's right on the line. And then our other point that we just did was -2, -6, and that's right there. So -1, -3, and -2, -6. Great. So now we have some different ways here of representing direct variation relationships, which are the same thing as proportional relationships. We found the constant of proportionality. We said that's the same thing as the slope with a proportional relationship. We represented it on the graph, and we emphasized that it goes through the origin. We wrote an equation to describe it, and we said, you know what? When it's proportional, we're not really going to add anything, are we? It's really just going to be y equals mx plus 0, because for proportional relationships, they always go through the origin, which is 0, 0. Then we made a table of points and even added a couple of more points to our graph. So now we know what direct variation means on a table, with an equation, and with a graph. Let's see how we could use this to solve some problems. The value of y varies directly with the value of x. If y equals 9 when x equals 1/3, what is the value of x when y equals 135? So first, I wrote out a place to answer this question with a complete sentence so that I know exactly what I'm looking for. Now let me go back and highlight a couple of things. I'm going to highlight this varies directly. That's important academic vocabulary here. Let me underline the question. What is the value of x when y equals 135? And now I think I'm ready to solve this. I'm going to use the table. Remember we used a table earlier right there? I'm going to use that again to solve this problem. I liked that strategy. All right, so let me get some space to write. We need an x column and a y column. I'm going to leave some space between them. Okay, x is 1/3. When x is 1/3, y is 9. I need to know what x is when y is 135. So that's what I'm trying to figure out right there. There's really a couple of different ways that I could solve this. Since this is a proportional linear relationship, I could think about this as a ratio table if I wanted to. So I could say, what number do I multiply 9 by to get 135? Let's try that out. It looks like 9 times 15 is 135. So then if I want to find out what x is equal to when y is 135, I can multiply by 15 on the left side. 1/3 times 15. That's like 1/3 of 15. That's 5. You could also think of that as 15 divided by 3. So now I know that when x is equal to, when y is equal to 135, x is going to be equal to 5. Great, and you can always use Desmos here as well. We could actually, if we wanted to, we could view this whole thing almost like a proportion, right? Let me show you what I mean. So I could write 1/3 over x equals 9 over 135. So I know this side has my x's and this side has my y's. I know some of you guys like to draw pictures kind of like this when you do proportions, right? So you could use a proportion here too. Remember, a proportion is just an equation that says two ratios are equal. So in this case, this proportion gives us the equation 1/3, whoop, my marker got too big on me. Okay, so in this case, it gives us the equation 1/3 over x equals 9 over 135. And of course, anytime we have an x like this and an equal sign, just an equation that we need solved, we can use the tilde, right? This could be a Desmos question. Just turn that into x sub 1, turn this into a tilde, and you can type this into Desmos. And Desmos will tell you that the answer is 5. So it's always a great idea to check your work with Desmos. Let's look at one more problem here. The total cost of gasoline for a vehicle varies directly with the number of gallons of gas put in the vehicle. The total cost of gasoline is $18.48 for 6 gallons. How many gallons of gas are put in the vehicle if the total cost of gasoline is $46.20? Here's what I'm being asked to find: the number of gallons of gas that cost $46.20. Let me go back and look for my academic vocabulary. Varies directly. All right, so we know we have a proportional relationship here. We also have some information that we need to pay attention to. Let's see. I'm going to draw a little box around this. That's the price for 6 gallons. And we know what we're looking for too, right? So those are important details to pay attention to. I liked the table strategy we used last time, so I'm gonna do that again here. But this time, instead of X and Y, I'm gonna have gallons and dollars. And I know that when I had 6 gallons, it cost $18.48. I wanna know what it's going to, how many gallons I can buy for $46.20, like that. So I could just use multiplication to solve this. I could say, well, how many times does 6 go into $18.48? That would just be dividing, right? And it looks like that would be 308. And what that 308 tells me is that's the cost per gallon of gas, right? So then I could get my answer by saying, well, what's $46.20 divided by $3.08? If I multiply both my dividend and my divisor by 100, I could divide some easier numbers instead. 4,620 divided by 308. Still not exactly easy, but not too hard, because 308 only goes into 462 once. And that division comes out to 15. So 15 gallons of gas would cost $46.20. I like that way of solving, but I do want to show you one that is a different way that's a little bit easier when you have numbers that are like this. You can see that decimal division. It was kind of a lot of work for me, right? So here's another way that I could have done it. I could have written a proportion. Remember, a proportion is a type of equation that says that two ratios are equal. So I could have written a proportion like this, right? And that's really an equation, which means Desmos can solve it for me. So I would then write this as a tilde. So replace my equals with a tilde and then write x sub 1. Then I can enter this into Desmos, and Desmos is going to tell me that that is 15 gallons of gas. So let's take a moment here just to review what we talked about. So first, we talked about what direct variation means and what it means for a relationship to be proportional. Y varies directly with X for proportional linear relationships. If you graph that line, it's going to go through the origin, or point 0, 0. Y divided by X for any ordered pair will give you K, which is your constant of proportionality. It's also going to give you the slope of the line. For your strategies, you can use a table, or you could use a proportion. Remember, a proportion is a type of equation. And if you are using a proportion, Desmos can solve that proportion for you. So that's a great way to check your work.